not like hurting our eardrums. Can we all hear me still in the back? We're good?
Yeah.
You can hear that okay? Okay, all right. So, hello everybody, how you guys doing today? Good. So my name is Mr. Andrew, this is Mr. Tyler, he's going to be helping me out today. And today we are going to be doing a little bit of science. So, before we begin, I just want to see by a show of hands, how many of you have ever been here before? To the Tulsa Children's Museum before? Ever? Wow, all right, we got some new people, cool. So if you guys have been here before, have you ever seen one of our science demos before? All right, great. So we have a lot of new people today. Cool. So we get to do these little science experiments every once in a while, and today we get to do something really cool. So we are talking about chemical reactions and pressure. So it kind of goes like this. If I have oh my goodness. If I have some paper towels here, right? Let's say I have a paper towel, I'm going to do something to this paper towel, and I would like you to observe what happens to it, and then tell me the results, okay? Are you guys ready? It's like really simple experiment. So here we go. Paper towel in 3, 2, 1.
What happened?
What happened to it? Yeah, I ripped it in half. It wasn't that exciting. But what do I have over here?
Piece of paper.
It's still a paper towel, right? Do I still have a paper towel on this side?
Yeah.
So did I didn't change the fact that it's a paper towel. Could I still wipe up some water with it? Yeah, or crumble it up or whatever. I could still do paper towel things with it. Now, what would happen if I took this paper towel and I lit it on fire? What would happen? It would burn up, right? So would I have a paper towel at the end of it? No. What would I have down at the bottom? I would have the trash, soot and ash. What's that stuff that goes up into the air? Ooh, the smoke goes up, right, and it gets hot. So by the end of that, can I take all those things and push them back together and make a paper towel again? No, that is because we would have changed our paper towel chemically. So that's what we call a chemical change or a chemical reaction. The first one was just physical. We just kind of made it into two pieces, right? So there isn't a whole lot of difference between it other than we made them smaller. But if we burned it up, it would change. It wouldn't be a paper towel anymore. So that's the kind of reaction that we are doing today. So I actually have a couple of different parts here. So the first part in my reaction is this stuff. This is called sodium bicarbonate, otherwise known as baking soda. Have you guys ever seen this before? Yeah, we probably have it in our houses. We use it for baking, or you can put it in your refrigerator and make it not smell very bad anymore. So that's what we use our baking soda for. Now, baking soda is really interesting because it reacts with something. There's a chemical reaction that happens with something. So let me go ahead and get some of our baking soda. We'll just pour it out. That works better. So we've got some of our baking soda. We're going to go ahead and put it inside of our flask here. There we go. You can see it. And the second thing that we're going to use today is this. Now this stuff is called citric acid. Have you guys ever had a lemon or a lime or an orange or a grapefruit or any of those fruits, those kind of things? And they're really sour and they almost burn a little bit, right? That is because they have citric acid inside of them. Now, have you ever seen baking soda and vinegar together? What happens with that? Do you know? It does make a chemical reaction, you're right. And so it makes a chemical reaction where it bubbles up and it reacts pretty fiercely. So I have my citric acid here and my baking soda here. Are you guys ready for our reaction? Yeah. So here we go, 3, 2, 1. So what happened? Nothing happened. Why did nothing happen? Well, what do we think? So we put the citric acid in and we put the baking soda in. Are they mixing together? No, they're not, because they're both solids. What's a way that I could get these to mix together? What do you think I could add in? Yeah, I could add some water in. So here, all we have to do is take a little bit of water, and once we pour it in there, it starts to react really quickly. So we had two solids and a liquid, and we are making a gas. That's what those bubbles show us. Now where is this gas going? Is it going down? Going to the side? Oh, it's going up, right. So this gas is going up and up and up. Now what would happen if I take my hand and do this? Now where is that gas going? Well, it's trying to go up, isn't it? Now it's kind of going all different directions, and I can feel it kind of pushing up against my hand here. So whenever I put my hand on top of this, all that gas is still trying to be released, and we are building up pressure inside of my flask here. Inside of here, we're building up pressure. So more and more of that gas is building up, and then what happens when I take my hand off? It just comes out the top, right? So that's the basic idea of our experiment today, but instead of this big flask here, I want to use something a little bit smaller. So I have an object here that some of you maybe have seen before, but probably do not. So this is something called a film canister. So way back in the olden days, before we had cell phones that we took all our photos on, we had to take our pictures with something called a camera. It was like the whole device was a camera. And this is the thing that we used to hold film in. There was actually physical film that you had to use for your cameras. So this is a little film canister, and you can see that it has a tiny lid on top of it as well. So if I take my ingredients and I have them in a tiny little form right here, just like this. So this is something called Alka-Seltzer. You guys might not know what it is right now. Your parents probably do. And this stuff has those two ingredients that we had earlier, citric acid and sodium bicarbonate. So what happens when we mix this with water? What do you think is going to happen? It's going to bubble up. Now, if it's bubbling up in this tiny, tiny little container, and I put that lid on it, what is going to happen to the lid? It's going to pop off, right? Because that gas is going to be expanding and expanding in there, and eventually that lid just can't take it anymore, and it's going to launch up. So, are you guys ready? Can I see it? Okay, so here we go. And because we're doing science, I'm always trying to be safe, so even though I do have glasses on, I'm going to put these on just in case something happens. So here we go, we've got our Alka-Seltzer. We're going to drop it down into our film canister, snap that lid on, we're going to back up and wait. So right now that reaction is happening, it's building up that pressure inside of it. You can even see some of those bubbles kind of like bubbling up to the top. And in just a couple of seconds, we should have a reaction. There it goes. Oh, that's good. All right, here. I got it, thank you. So, that was pretty cool, right? Now, I think this one is a lot of fun, but why don't we change it just a little bit? So I have another device that I want to show you, and it looks like this. So this is just a tiny little piece of plastic tubing. It's not very important all by itself, but we can use it to make a timer on our little canisters here. So if I put a little bit of water in here, and I take this piece of plastic and set it inside, and then I take my Alka-Seltzer and put it on top. Is that Alka-Seltzer reacting yet? Has it gone into the water yet? No, it's not. It's hiding out right on top there, right? So I can take my cap and set it on the rocket, and is it going to do anything? No, it's just going to sit there until what? What do I have to do to get it to start reacting? So I could shake it, but I think then the water would all just fall back down to the bottom. So what's an easier way? Yeah, well, why don't I just flip it upside down? What do you think? So it's just gonna stay here until I flip it upside down, and then we're gonna get a pretty big reaction in. Are you ready? So here we go. Again, our timed reaction in 3, 2, 1. All the way upside down. So that chemical reaction has started. That chemical reaction has started. Again, we are increasing the pressure inside of our film canister. And as it builds up and builds up, eventually that lid just can't take it anymore. And we're going to have our canister launch up into the air. There it goes. Oh, that was so close. Thank you. So, launching one of these is pretty cool, isn't it? I think that's fun, but what if I have more of them? If one is good, more is better, right? So what if I did like 2 at one time? Would that be better? Yeah. What about 4 at one time? What about 8 at one time? That's good, because I have prepared 10 of these So I've got 5 over here. And I have 4 over here, and I'm going to add this last one in. And Mr. Tyler, would you mind coming on over? And he's going to help me finish this off. So we've got our water, our little tablet there, and we'll set that lid on. So once we complete this, let's go ahead. I think we're going to make a little bit of space here. And we'll take this and lift that up. There we go. So we'll take our little containers here. So we've got them all set up. There are these Petri dishes that we're using to hold on to them. So once we flip our set of them, they're all going to start reacting at the same time. Now remember, there are 10 of these that are going to be going off. So we're going to kind of count through. Make sure that all of them have gone off before we start moving around again. But by the time this is over, there are going to be kind of film canisters all over the place. So I would really appreciate it if you guys would help me collect them. And you can just bring them back up here and set them on the desk. So here we go. We're going to do our last rocket launch, and then I'll let you guys get back to your plane. Are you ready? So here we are. So just because I love a countdown, can we all count down? Yeah. Here we go. All right, ready? And in 3, 2, 1, and flip. We're gonna take that top one off, and there they go. Let's go ahead and back up. I'll stay up here with these. So there again, all of them are now reacting inside of each of their containers. We're probably gonna get a couple of these going sooner. Let's see, which side is going to launch first? Who knows? Oh, there we go. So we got 1, 2, 3, 4, 5, 6, 7. Only 3 left. There goes the last one. Wow, those all went up really good. All right, guys, thank you so very much for being here. I really do appreciate it. I hope you have an awesome rest of your time here at Tulsa Children's Museum. Discovery Lab.